All right. Think we are live. Not that. All right, microphone check. There we go. Batteries look fine. And I guess we're live. Hey, Need Sleep, welcome aboard. Today we will be doing things with cameras, I guess. Actually, I'm glad the sound is good. I did check, but you never know with these things. Let's see. I actually need to check something camera related. So if I go to a site, so yes, I allow it. And can I choose which camera? No, I only have the one camera in right now. Then hold on, I think I need to connect an extra camera because I want to take some pictures. We're gonna be doing things with cameras in the stream. So I need some cameras for my cameras so I can camera while I camera. So we can take this camera, which I have mounted next to my good one, and see if we can connect that. Hopefully it will show up. Looking for spare USB holes back here. There's one. Hopefully this connects okay. Nice thing with having a wireless microphone, I can at least go behind my computer. I actually don't expect to need the headphones, so now I have another camera. I do. Perfect. Great. Can I tell this? To do camera selection? No, maybe not. All right, so checking which cameras I do have. So for 4 cameras detected, I wonder what they all are. Let's see. Linux list cameras devices. So W4L2, so would you for Linux 2? Dash list devices. Okay. So they expose 2 devices each. That's good to know. And we should be able to use the OBSBot tiny camera. So that's a small AI-based camera that I have sitting here on my monitor. It's not super quality or anything, but it can actually track faces, which is pretty neat. I'll actually enable that now. Yeah, and it tracks me. All right. So the project for today is looking at this Elixir library, which is work in progress, so be kind if you try it. It connects Elixir to, well, connectable to OpenCV. Now, OpenCV is Open Computer Vision, and that will allow you to do things like detect faces in an image or anything like that. Hold on, just gotta reshare this, the going live tweet a little bit. So give me a moment. Sure people get a chance to see it. So there, that's enough self-promotion. So then let's take a look at what this is. So I've done a few things with OpenCV in Python before, so it's not entirely new to me. I, for example, know a little bit about getting face detection, basic face detection to work. So not recognizing who the person is, but saying, there's a face here, and drawing something on top of it, for example. So because that's a thing I managed to set up before with OpenCV, and it wasn't all that hard, and there are good examples, I figured that was a good place to start with trying this evision library. So this is a Python example of using a hard cascade XML data thing for, and then we can capture an image and find face in it. First, let's make sure this new camera I connected can be captured from. So I've already installed and compiled the evision project inside this Phoenix project. So just made sure that worked before I went on stream. So let's see. Actually, we can do ix.phoenix.server. That will give us a Phoenix server that should serve the static for us. Images. Which would then mean we have, if I go to /images/my face PNG, right now that gives us nothing. Now, let's see. Video capture. So this is the example. We aren't going to use number 0, can't open camera by index. That's not where our camera is. So let's try obspot via video 3. Cannot query video position, that's fine. But it seems to have opened a stream. So this cap mat is a reference to a captured matrix, I believe. So a matrix of pixels. That's not super relevant to exactly what we're doing, but then I want to do this, but I'll write the path myself. So OpenCV dot I am right. Now I want to write it to priv static images my face .png, and I want to write that cap mat. Is there anything on the end there? No, that seems like all of it. That wrote something. Ha! Oh, that's a derpy angle. Not my finest moment. Let's capture a new one. And just overwrite that one. Perfect. Nailed it. Exactly what I want. It's flawless picture. So a fun thing about this camera is that it will, since it will track my face, I can actually, so now I'm off camera for the stream. Can I read? Can I write a new my face? And it has refocused the camera over to where I went, which is neat. That's unrelated to this. So there's always already a bunch of face tracking inside of this camera. That's not what we're dealing with as far as we're concerned. That's just a webcam. Now, if we want to find a face, we can use this hard cascade thingy. I don't super care about what this is and how it works. I just know it tends to sort of work. So I did a thing earlier. This was a good command. So this told me where in this where in the structure we can find these. So we need a frontal face, paw, an eye tree, eyeglasses. So I guess this is support for handling glasses. So both of these are things we want to find. So let's write some code around this. And shrink that one, and shrink this one. And the code editor. Take up most of the space. Yeah, we can write it in here. So we have this. I want the base path. So let me know if you have specific questions. I'm happy to go on a tangent to explain some things. Am I not allowed to select that? There we go. So I want, this is the data part of it, and this cascade frontal. And then we want this one. Frontal face default, but we want frontal face out, apparently. Not sure how much it matters. I imagine there are slightly different methods. And then we want to find the OpenCV classifier. So there's a lot of stuff in here, though. So I wonder if the cascade, this cascade classifier is in there, if I need to do anything with it. The face cascade at load. Let's see if we can figure out what that would be. Meta type. So there are more examples. Person who's doing this has been doing some very cool stuff. So there's a live book with the examples of using this that might tell me something. We'll see. Just one good thing with this is that you can read and write images in a good way, capture images from cameras. That's going to be useful. Just that. Hey, image C, Z, something like that. Yeah. I don't see a clear idea of what that would be. Currently available modules, Calib, What is this particular module, the Cascade classifier? So that's an object detect. I don't know. I don't know if we will have this. Let's see. There's a ton of stuff here. Video capture, utils. I know there's a bunch of tools we need for loading the Cascade sample files and stuff, but I don't know if we get everything we need. There's a lot of functions in this module. So this is being generated from the Python bindings, I think, or similarly to the Python bindings. Hold on. Tons of functions. EV, that's a prefix that had a few functions to it. To keep an eye, see if there's something Cascade related here. Could be that these are essentially constants, or possibly types. Not entirely sure. Cap, CD cap. Okay, I think we ran out of buffer. That's fine. So OpenCV dot. Let's hope we can do more of this. So if I just want to do the find file, that would be let's just gonna call this try. Frontal. And then I know there was an OpenCV dot samples underscore find file. So we should be able to use that one. To do pathojoin baseball cascade. frontal. And then eyes. Cascade eyes. And then I can just return frontal and eyes. See what we get. So I try. Sweet. It found both of them. Now, is there an open cv.load or something? No. So here's where I would need this cascade classifier. And I don't think I'm not sure that exists in here. Mm-hmm. So it's possible that we could make it compatible with that module. Don't know how much work that would be. But top of mind, it doesn't really seem like it necessarily has has the modules I would want. So let's see. It has ML, it has core. I'm curious where the cascade classifier lives. As far as OpenCV modules. Okay, it's object detection, probably. Yeah. And if we check the evision list, that's not in there. So that probably won't work. Now, it does have others. So for example, stitching, features 2D, plan, high GUI, image codecs, image processing. Okay, so what can we do? TS? The OpenCV modules, what's TS? Don't know what that is. Image processing. 2D features. Image stitching. Actually, computational photography could be fun. In painting, what's that? OpenCV photo module Python example. Let's see if we can do something fun. Getting started with images. That's a little bit baseline. I want to process an image in some way. Make an image blurry. Detect the edges, maybe. Oh, this side is screwed up. Image contour. Okay, OpenCV, improve image quality. This could be something to play with. Edge preserving filtering, that sounds fun. It's in the computational photography submodule under the photo module, so we might have it. Edge preserving filters. So let's see, OpenCV dot, we do that photo, no? Edge preserving filter, look at that. So we could send some stuff to it and it would do things. Let's try it with some defaults and just see if we can, what that does to an image. So let's skip all of this HAR business because we don't have the module that uses all this. Throw that out. Go back to the code which lets us capture an image. This example, and I think we were using number 3, so let's say okay, cap video capture dot video capture 3, so that's device 3, and okay, that's the matrix we capture. So we snag a picture from the camera. Then we want to do something to it. And in this case, we want to do OpenCV.edge preserving filter, and just pass that in. And just to do something more, we can actually open cv.image_write priv static images original for PNG. That's where we write the math, and then enhanced edge map. Okay, so with this, should just be able to recompile our module and run that. Yeah, the device is busy. And one of the reasons for that could be we haven't closed it. So could it be that we have a cap already? Yeah, we do. Let's change this code to take a cap because I don't want to bother with opening and closing the video. Recompile that. Nice try. Yeah. That went better. So in this case, we'll be able to go to original.png. And we should be able to go to enhanced. Such an enhancement. It's magnificent. Very, very strange. I think it looks weird, but that's okay. All right, so these are our comparisons right now. It definitely did things to it, so the system works. Things were done. So let's try passing some flags, and I wonder if we can get some info about that. Edge preserving filter /2 param. Yeah, so it takes these sigma s and sigma r, and I wonder if that's a keyword. I hope it is. That would be the nicest API, but I would understand if that hadn't been possible. Flags. 1, then we do recursive filtering apparently. Sigma s equals, okay, let's do this 60. Sigma r equals 0.4. Just grabbing these numbers from the guide. I have no idea what they are. This is not how you write those in Elixir. If you're in the chat, feel free to say hi, and don't forget to ask questions if you have them. So now we capture something new. Well, it's a new image. I don't know that it was all that much of a difference. I mean, it does blur things while preserving edges. I'll grant it that. They're like, it doesn't lose a ton of detail for being something where you blur. It's definitely an effect. Not sure it's an effect I would want. But yeah, that sort of confirms it working at least, which makes me happy. Now, if we, let's check in painting, denoise, and HDR imaging. I don't know which ones I would want to go for. What does this mean? OpenCV in painting. Don't know what that is. Oh. It tries to fix errors in a picture. That's neat. Not something I can easily use right now, I don't think, but denoising, so that's always nice. I guess there's a mix of techniques you would use to just generally improve an image. So detail enhance. Non-photorealist. Okay. That's detail enhancing filter. Okay. That's neat. Pencil sketch filter, yeah, that doesn't matter to me. Stylization filter, that seems like fun. That seems much more fun than what we were doing. So let's try that one. So Sigma's there, and then this one goes to 0.0.7. We can't actually keep writing these two different files, so we get all the little experiments. I believe you can do a lot more sort of advanced stuff if you really get into the machine learning side of this. I mean, this is plenty fun and useful already. Let's see, that's a new one, or rather, this is an old one. Edges, that's perfect, mid-speech. I really should learn to shut up sometimes. And then I really like the background, actually. This I like. And I'm not sure I care for this guy, but that lamp was good too. This is fun. I mean, this one's fun. I would consider putting this as a filter on my video stream just constantly. It would probably be interesting to see in action. Though it did seem a little bit slow, so I'm not sure how feasible it is for real time. That could have just been the writing to a file thing as well, or that could be part of it. Let's see, detail enhancing. So this one doesn't actually sort of trash the image entirely. Still looks sort of realistic. I mean, just the fact that someone got us to just having access to large parts of OpenCV. I love it. OpenCV is so much fun. And like, there's already support for having it work with nerves. There are pre-built images. I don't know exactly how it binds into the camera support. I guess since it's doing something similar to what Python is doing, and OpenCV probably already talks to Raspberry Pis by default, it might be using the correct libraries under the hood. So you might even be able to use the high quality camera of the Raspberry Pi, or whatever you connect to it, or the sort of normal Raspberry Pi camera. But then and you get the device processing and all. Yeah, it could be good. Something to play with for sure. At some point. There's no... Oh, right, maybe I should also write it to a file. Oh, that's weird. And it's not wrong. That is more detailed. Also, this webcam right here that we're using for this test is making me appreciate how much better this camera is. I really should be capturing some pictures from it, but I don't think we can grab that one. Right now. I could try. The worst thing I can do is probably screw up the camera on the stream, which is not the most important part of the stream right now. So we can try this. I know this showed up as camera 1 earlier. Can't open camera by index. Camera 2. I wonder what I got. Just moving my head back and forth. I think I just locked up the camera in the stream. So yes, we try to do something with it now that we have it. Let's see. Now I shall try cap 2. What? It hit an error? I'm surprised. So it might just be that didn't work very well. I'll release that. I'll see if I can fix this camera. It's dead, Jim. Been too rude to it. I'll restart the camera, see if that helps. Anyway, I think the stream is still running along, so maybe my face is just frozen in time for the rest of the stream. That's not the worst that could happen. So let's see if we can open the one we were using. See if that still works okay. Yeah, okay, that worked. Has that zoomed in a lot? Wow. Creepy. Yeah, it decided to... Oh, I think it got reset when I was fiddling with video settings, and then it decided to crop to the size of my head. That's nice. It has a bunch of that fun stuff built in. I can try another capture, see if it's still zoomed in. No, now it's zooming out. Now I did not get the full image. There we go. That's a crooked smile if I ever saw one. Sure, let's see how that looks in all the other styles. Oh dear, don't outline people's teeth like that. Now, how to make... Oh, super resolution. this is something I'm curious about. Super resolution refers to the process of upscaling or improving the details of the image. Follow this blog to learn the options for super resolution. So, no, maybe, I don't know. Papers, models, da 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 da. Contrib. EDSR. So is this, this using convolutional neural networks. Now we're in the AI space firmly. Let's see if that's DNN, but I think DNN super res is probably an addition. There, super res. Don't think that was in the supported modules. No. Maybe stitching is good. What can we do with OpenCV stitching? If you see a module you would like me to poke at, feel free to let me know and I'll give it a whirl. I still would rather have this camera revived. Just not the ob spot. Ah, well, I don't want to go around the computer and plug and replug it, which I think is what might be required to get that one. So, oh, so that's what that is. Creating a panorama by stitching images together. Now, I can make this camera, so this camera is tracking my movement. So that should mean that I could stitch it together. So what will it take to do this? We'll briefly review OpenCV's image stitching algorithm that is baked into the OpenCV library itself. Unlike previous image stitching algorithms, which are sensitive to the ordering of input images, the Brown and Low method is more robust, making it insensitive to ordering of images, orientation of images, illumination changes, noisy images that are not actually part of the panorama. Sounds good to me. So create, do you have to do a create stitcher then, or? OpenCV.stitcher create. Okay, that's there. Blah bitty blah blah. Blah bitty blah. Parse. When are we actually going to do it, though? All right. So you take a bunch of images, you create a stitcher, then you call stitch. How do you stitch? Okay, that's Stitcher. Oh, Stitcher create and stitch. And, all right. Hmm. So just stitching these together. What does stitch /2 want? Self and images. So I'm guessing it's a list of these matrices. So let's comment out all of these. And now let's, let's say we want 4 images. So read out 4 images. That should give us a list. This should give us a list of those matrices. Now, if it reads instantly, constantly, that's not the best. So let's delay every run with about 500 milliseconds. This should mean it takes 2 seconds to take all 4 pictures. And then we have a set of images. And we should be able to, okay, Stitcher equals opencv.stitcher.create. And then to okay, stitched math is what I would expect the result to be. So opencv.stitcher.stitch Stitcher images. And then I want to just write this one stitched. I think that makes sense. So now, if I do this, well, I should probably open my, do I have a cap? I'm not sure. Yes, I do. Just didn't remember where I was. So now, just checking that it's still tracking me. Yes, it is. So I could start this, and then I'll stand up, and then I'll strafe over a bit, give it some things to capture, or I'll at least move around for those 2 seconds where it should be capturing 4 images, and then it should be able, ideally, to stitch them together. Oh. It failed at some point. Error. Oh. So line 17 failed. Create. Maybe we should have Stitcher create. opencv.stitcher create. Will that work? Invalid stitching mode. What does it want? It wants a Stitcher mode. Create Stitcher, create Stitcher, 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 Stitcher. Now, that makes me curious what options the stitcher is supposed to take that we're not seeing. Try use GPU false. So we could pass it false. No, that argument invalid stitching mode and function create. Mode. Camera models. Valid stitching mode. OpenCV. In here somewhere we had a mode. Come on. Panorama. So do we have OpenCV dot stitcher dot so we created with a mode. The mode is Stitcher Panorama. How do I get to that? I'm not sure. That's the fun part. There's a create zero, but the create zero fails, which I think is novel. That one also fails. Set blah 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 blah. Can't create a stitcher. If it fails at creating a stitcher, I think I might be solely out of luck, because I think the rest could have a chance of working. But if we can't create the stitcher itself, mode, scenario for stitcher option. This is usually determined by the source of images to stitch and their transformation. Default parameters will be chosen for operation in given scenario. Return stitcher class. Maybe there's just not much point to creating it beforehand. So this is the tricky part. There might be a good way to do this that I'm just not seeing, which is unfortunate, but hey. Not really the fault of the person creating this. It's just that I can't guess their brain all the time. And it's early, so it's an early project, so it's not necessarily all that documented. There's a surprising amount of information already. Now, the Stitcher create as an OpenCV4 function. So did this have a decent example? Say 4. Yeah, since I can't run the create, I think I'll I'll wrap that up. But yeah, we at least know that so this photography enhancing stuff works. Something we could do before we wrap up is to try to do something slightly more wild with that. So instead of this, I'll just comment this out. Never mind, I'll delete it because apparently I don't know how Vim works. So instead of always working off of the original, yeah, maybe we should still read an image from the camera. Excuse me. This one, we still need that one. Remove this. So now we just overwrite. We overwrite. Oh, no. So we make that one, and we make this one turn into that one, and we turn this one based off of that one. We write that one and that one. That should look absolutely ridiculous, ideally. Something wrong? Oh. So we'll see the original and the one with the edges. So this is the original. This is our art piece. Actually, I think it's a sort of net positive. I think it improves on some of what we had. It's better than the other sort of in-betweeny steps. I bet you could get interesting results with shifting the order of these as well, because each builds up on the last one. Yeah. This is not a bad image to end on. All right, I think that wraps it up for now. I'm super excited to have this tool remember that everything that you can get into Elixir means you can also do cool real-time things with live view with it. And I mean, there are already demos of what you can do with this on Livebook. I think the example available is identifying whether an image is a cat. So that's a useful tool right there. Yeah, this makes, maybe I should smack this up as the thumbnail. I'll save this image. Enhanced Losh. Yeah, that's what I'll save this as. All right, but thanks for watching.